Welcome to Pharma Knowledge Hub. Today in our channel we will discuss about the medicinal chemistry. Topic is medicinal chemistry. Here in medicinal chemistry, the chemistry which deals with the medicinal properties and drug medicinal products is called as medicinal chemistry. These medicinal chemistry is interlinked with the pharmacology and pharmacognosy of the drugs. The introduction of medicinal chemistry. Medicinal chemistry is defined by the IUPAC Specific Commission as it concerns the discovery on the development of the compounds at the molecule level. It is a application of chemical research technique to synthesis of pharmaceutics during early stages of medicinal chemistry development. The first of all medicinal chemistry development, some chemical researches will be occurred. That chemical research techniques can show the pharmaceutics of the drug. During the early stages of medicinal chemistry development, scientists were primarily connected with the isolation of medicinal agents. The scientists connected with the isolation of medicinal agents which found in plants. We are studied that as a pharmacognosy. Today, scientists in this field are also equally concerned with the creation of new synthetic compounds. That is nothing but drugs. Okay. In medicinal chemistry, the almost always greater towards the drug discovery of development will be seen. Okay. And in here medicinal chemistry, the chemistry trying to process of synthesizing new pharmaceuticals. To synthesizing new pharmaceuticals, this chemistry will be used mostly, and most chemicals work with a team of scientists from different disciplines that includes biologist, toxicologist, pharmacologist, theoretical chemistry, microbiologist, and biopharmacists. So many persons are there who work with the chemists, nothing but professors. Okay. In scientific field, so many workers are there, like worker teams. In that team, the scientists as means the scientist who is the scientist who belongs to the each biological scientist is there in this medicinal chemistry. Okay. The scientists who belongs to the departments like biologists, toxicologists, pharmacologists, theoretical chemists, and biopharmacists. Each person from each department, each person is selected for the medicinal chemistry chemists. And in this medicinal chemistry, the discipline combines experts from the chemistry and pharmacology to identify and development the chemical agents. Why the chemical agents will develop further therapeutic use and evaluate the process of existing of the drug. Okay. Here, this medicinal chemistry laboratory, all department professors are there, all department related scientists are there who are belongs to the each department. Each scientist is there. He worked about the particular drug. Here one example is there. That one example is when we take in the digitalis as an example. For the digitalis, it is obtained from the digitalis purpurea plant. So we need a biologist to pharmacologist to study about the microscopic structure of that plant. Okay, and then we need a pharmacologist because to know the side effects and therapeutic use of the drug, and also we need a pharmacist to analyze that drug which is in which form, and we also need a Sutics department related one work. Sutics department a professor who is belongs to the Sutics department to know how which medicament is suitable for that in which form we will take in that drug. So that's why these all are comes under the medicinal chemistry. In medicinal chemistry we have just know about the structure and structure activity relationship of the drug and medicinal uses and some adverse effects. Mainly in medicinal chemistry we just study about the mechanism of action and structure of that drug only, but we need to develop the drug. We need all persons like a biologist, toxicologist, chemist, microbiologist, biopharmacist. So that's why medicinal chemistry is combined with the molecular biology, pharmacology, pharmacognosy, and structural biology, and also chemistry. You can observe here a flow chart. Okay, and the physicochemical properties in relation to the biological action. The physicochemical properties in relation to the biological action. What are the physicochemical properties of the drug which relate to the biological action? Means here some physicochemical properties are there. They are solubility, partition coefficient, dissociation constant, hydrogen bonding, molecular refraction, ionization, drug shape, complexation, surface activity, protein binding, bioisomerism, chelatation, and last one is geometrical isomerism. These are the physicochemical properties of a drug which relate to the biological action. A drug contains these all properties to develop as a drug material. Here we will study about each one in this topic. Okay, first one, the solubility. Where it comes to the solubility of a substance at given temperature is defined as a concentration of dissolved solute which is equilibrium with the solid solute. Solubility means when we take the water and we add sugar in it, the sugar will be soluble in water. Here the sugar is a solvent and the water is a solute. Sorry. The sugar is a solute, water is a solvent. Okay. The solubility is depends upon the solute and solvent as well as temperature, pressure, and pH. When we increase the pressure or temperature, for example, we are already adding the sugar into water, then we mix it with the spoon. What will be happen? Easily dissolved by the spoon. That spoon we are mixing. The process is pressure. We are applying the pressure. So that's why that will be easily dissolved. When we put that solution onto the stove, then what will happen? It will become a syrup fastly. So that's why the solubility is depends upon the solute, solvent as well as temperature, pressure, and the pH. The solubility of a substance is ratio of the rate constants of equilibrium in a given solution. The solubility of a organic medicinal agent may be expressed in terms of affinity. According to that affinity, we can differentiate the equilibrium of the solution. And the atoms or molecules of a organic substance are held together by the various types of the bonds. We already know that. What are the bonds? Means hydrogen bonds, van der Waals bonds. Okay. The solubility is involved in solute solvent, solute soluble, solvent solute interactions. These interactions can be two types: intramolecular, intermolecular. The most intermolecular interactive forces that involved in the solubilization process are four types of bondings. What are the four types of bondings? Means van der Waals attraction, dipole-dipole bonding, ionic bonding, and indipole ion dipole bonding. In van der Waals attraction, the van der Waals attraction includes dipole moment also. Okay, so here the weakest intramolecular forces, that is nothing but 0.5 to the 0.1, which occur between the non-polar groups. What are the example of non-polar groups? Means hydrochloric acid. Okay, the hydrochloric acid is the best example for the non-polar groups. Do not dissolve in the blood. They are highly distance of temperature dependent. These van der Waals attractions are the weakest intramolecular forces. So that's why here non-polar groups will be occurred. And when we comes to the dipole-dipole bonding, these dipole-dipole bonding, the forces occur when electronegative elements are attached to the carbon atom. The carbon atom having stronger bonding, we already know that is nothing but 1 to the 10 k calories per moles. Okay, this is the strongest bonding, that is carbon bonding. And electrostatically between the electron deficient and electron rich atoms, nothing but dipoles. These dipole-dipole bonding is the fourth and strongest bonding. And hydrogen bonding is a specific bonding to serve the prime contributed to the hydrophilicity. In dipole-dipole bonding, the two types of bondings are there, that is one is carbon bond and another one is hydrogen bond. In carbon bond, the strongest bonds are occurred. When we seen in hydrogen bonding, the bonding of molecules will be contributed to the hydrophilicity. Okay, and third one, ionic bonding. It is a electrostatic attraction between cations and anions. Here we can see in the ions. What are the ions? Two types of ions, cations and anions. Cation means positive, which are having positive charge is called as cations, and negatively charged atoms are called as anions. These ionic attractions are common in inorganic compounds. So salts of organic molecules are relatively strong, which shows these ionic bondings, like for example sodium, calcium. Okay, and when we move to the fourth one, ion dipole bonding. These ion dipole bonding is electrostatic force. The electrostatic force between a cation and anion, which is relatively strong, that is nothing but the 1.5 k calories per moles. And the low temperatures and distance dependent. These are the low temperature bonding and also distance depending. These are all the cations when moves to the anion side and negatively charged atoms are moved to the positively charged atoms. The positively charged atoms moves besides to the negatively charged atoms. This is about the ion dipole bonding. These are all about the solubility. These are all subparts of the solubility. The four types of bonding: van der Waal bonding, um, van der Waal attraction, dipole bonding, ion dipole bonding, ionic bonding. Okay. Second one is second physicochemical property of a drug, that is partition coefficient. The ability of a drug which is dissolved in lipid phase, the aqueous phase is also present after referred as lipophilicity. The lipophilicity can be best character of the partition coefficient. It can be defined as the equilibrium of a drug concentration for unionizable molecules in two phases. In partition coefficient, the concentration of organic molecule is inversely proportional to the concentration of aqueous molecules. We can see the ability of a drug in this partition coefficient, the ability of a drug which is dissolved in lipid phase. We can see the different phases between the lipid phase and the water phases. This is explained by the partition coefficient. The contribution of each functional groups and structural arrangement helps to determine the lipophilicity of a molecules and majorly influence the drug transport. Okay, here we can see that the drug is there, concentration of organic phase is divided by concentration of the aqueous phase, that is equals to the partition coefficient. The drug which reached the site of action from the site of application, since blood distributes drug the must penetrating and transfers many cells to reach the site of action. Here the drug reached to the site of action from the site of application. First we have to apply the, when we taken as a example, for example, that is cream or ointment. When we apply on the skin, it will be reached to the site of action, then it will be distributed into bloodstream and which penetrate and transfers many cell to reach the site of action. This is about the partition coefficient. And when we came to the hydrogen bonding, the hydrogen bond is a special type of dipole interaction between the hydrogen atom and nitrogen atoms. Okay, these are the in hydrogen bonding, the dipole interaction will be seen. For example, A and B are represent as a polar bonds. In these hydrogen bondings, the A is attached to the hydrogen bond is a one molecule and another B is attached to the nitrogen group, that is another molecule. Okay, that can be represented by the dotted lines or bond angles. Okay, generally these hydrogen bondings are classified into two types. They are intermolecular hydrogen bonding and intramolecular hydrogen bonding. In intermolecular hydrogen bonding, the hydrogen bonding occurs between the two or more than two molecules where we are intermolecular hydrogen bonding. In intermolecular hydrogen bonding, the hydrogen bonding occur within two atoms of same molecule. This type of hydrogen bonding is commonly known as intramolecular hydrogen bonding. Whereas in intermolecular hydrogen bonding, the hydrogen bonding occurs within two atoms are same, but the compound resulting of polymeric agents of hydrogen bonding in ammonia is differ. Okay, sorry, we will get confused. First one is intramolecular hydrogen bonding. In intramolecular hydrogen bonding, the hydrogen bond which occur within two atoms are same molecules. In two atoms of same molecule, the bonding is occur between two atoms, that is called as intramolecular hydrogen bonding. Where in intermolecular hydrogen bonding, the hydrogen bonding occur within two atoms of different molecules. Okay, different molecules, between different molecules the hydrogen bonding will be occurred, that is called as intermolecular hydrogen bonding. That is the small difference between intramolecular and intermolecular. In intermolecular hydrogen bonding, the solubility will be increased by the bonding with the water. In intermolecular bonding, the solubility will be increased and temperature also increased. When we came to the intramolecular hydrogen bonding, here the chelation will be occurred between the organic compounds. In between organic compounds, the chelation will be occurred, and which develops between 5-membered ring, that is benzene ring or also any another type of ring, and decreased in blood boiling point will be seen in intramolecular hydrogen bonding. The boiling point will be decreased and solubility also decreased. In intramolecular bonding, the boiling point and solubility are decreased simultaneously. Where in intermolecular hydrogen bonding, the solubility increased and also boiling point also increased. That is the small difference between the intra and intermolecular hydrogen bondings. Okay, thank you.